You look at number 6.
Yeah?
The 1. The 1 is equal to 1. And
wait, what? The 1 is equal to 1?
Number 6. Oh, you don't have.
Yeah, show me number 6.
You look at number 6, there's an equal sign to 1. And number 5, there's that minus cos.
Wait, which page are we on?
Oh my God, 42.
42.
Yeah.
Number 6, there's an equal
Number
sign.
5 and 6.
And it's an equal sign, yeah?
5 has minus cos x.
Yeah?
And 6 has that 1 after the equal sign.
Yeah?
What happens to these numbers that don't have division? Because in the answers they are not explained at all.
What? I don't...
Okay, do number 5.
Okay, thank you. Number 5 and 6. So, number 5 on page 42. Sin x dy dx minus cos x equals 0. So I just take the cos x to the right, yeah? And cos divided by sine is there, yeah? And if I cross multiply I get this. So y is, I need to integrate cos over sine. Now the only way to integrate this is with a substitution. I make u equal sine x. What does du dx equal? Cos x, yeah. So this actually can become a u here, and this is du over cos x, and a cos x here originally, yeah? Cancel, cancel, integrates to what?
Oh.
Log u, but what's u?
Sine x.
Groovy? Groovy?
Yeah.
Okay.
But you see, okay, so you wrote.
What? What's the beef? I forgot my C. Well, no, I didn't forget my C because I can find the C. I say that you get a 0 here when you use pi over 2. Sine pi over 2 is 1, log of 1 is 0, so C is 0. So the answer is y equals log sine x. Continue. You still want 6?
Yeah.
Are you sure? Okay. Have we got everybody?
No.
Who?
Not very
Yeah, I know. Yes, I know. Don't get my jokes anymore. Right. The red-haired lady is from China. Really? Okay, continuing. What should I do first?
Cool
Factorize.
Cool down dy dx.
So I get dy dx equals 1 over 1 plus x.
Yeah.
Integrate y equals log 1 plus x plus c. And the info is, when x is 0, this is 1. Is that what I said? No, when x is 1, this is 0. So this should be 0 equals log 2 plus c. So c equals minus log 2. This is the mistake, is it? So I get y equals log 1 plus x over 2. Whereas I probably don't have the over 2.
Yeah.
No, I don't. Groovy. So I'll just remember to fix that now. Okay, so that's page 42. Anybody else with other questions on page 42? Lee, any questions?
No.
You're that smart. You're not sure what to... How can I answer this? I want to say yes, but I don't want to seem like a jerk. Any questions, Lee?
I didn't do.
Oh, now the truth. Truth comes out now. Right, further... What the heck is this lesson? ODs. No. Well, I just want to fix that answer. come on, where the ODEs. And now on to, whoops.
Is this our program?
Oh yeah, I typed all this.
Wow. How many years it took?
How much is it? For that
1.
now?
1 year.
You know, like I said, I'm a busy man, and I'm busy because I have so many different things I'm doing.
You prepare it for a year and then you can do that.
Yeah. Correct. It's true. It's all true. What are we looking at next? Practical problems? Okay. Actually, hang on. Let's see. ODE numerical methods. Practical problems. Yeah. Okay. Right, which one first? Now, we do remember that there was the typo, didn't we, in Sipp's law states that given some book, the rate of change of frequency with respect to rank. I fixed it. Yeah, okay. 4, and just... Yes? I'm just looking for something here.
It's really easy, but maybe can do it. Okay.
3! Let's have a look. No, KJ. No. A fetus can do it. We're weird. Right, 3. Consider n, which represents the number of nuclei left in some material that's decaying. The rate of change of n is proportional to the amount of nuclei n remaining. Okay. Let me just close these. Right. So in this question, what I'm saying is, you have some material, and it's decaying, and n represents how many molecules you have left. But what I tell you here is, the more n you have, the quicker it's decaying. I actually tell you that the rate of change of n with respect to time is proportional to n. Now, if you want a picture, an example in real life of this, if you think about a bottle of water, the more water that's in here, the faster it will spray out. And as it reduces, the water gets slower. It's kind of the same idea here. As the n decreases, it actually starts to lose. It slows down how quickly it's losing. Yeah. What's the first part? What's the equation? Now, you don't have to, but I would like to put the minus in now because I know I'll get the minus later. But you don't have to. You don't have to. You can do this whole question with the plus and you'll get the same answer at the end. It's totally fine.
If I put minus
Yeah.
okay, then shouldn't I plus result at the end?
Yeah, positive result at the end for k.
Yes, so they are different.
But the equation you form will be the same. You see, my k will be positive, but it will still have a minus in the power at the end. If you don't put the minus in, your k will be negative, and you'll still have a minus in the power at the end. Yeah? Okay, look, just plus, it's fine. It doesn't matter. Why am I putting the minus in? What's my rationale? Well, because it's a constant. I'm free to put the constant in any form. We simply choose k, but I could have said k over 2. So I have quite a lot of freedom to choose whatever way I want to write the k. The only thing I couldn't really do is this. I couldn't say equals k squared n. Why can't I use this to represent my constant? What could be
negative.
Yeah, like I've restricted my constant to only be a positive here, which I don't necessarily know. Even if I put the minus in, I'm not actually committing to using a minus, because if the k was a minus, then that would in total make a plus. I just know from experience, when we have things which are decaying, the minus in the equation will make it just a little bit neater to solve. It's not necessary. Part 2 is to find the solution here. Well, you know the solution here. If I cross multiply and integrate, I get log n equals minus kt, so plus c. So I get n equals e minus kt plus c, which will be n0 e minus kt.
How do you know n0 there?
What else could it be?
Any initial, any letter could go there.
Any letter could go there.
Like A
Yeah.
instead of C.
Yeah. But I know that when t is 0, this constant represents what the n is. So I'll call it n0. And finally, I tell you what n0 is. So I tell you that n will be 0.1 e minus k0. So n0 is 0.1. And also I can give you the t when the t is what? No, sorry. When the n is 0.05, it's because the t is 5,600. Yeah. So the k is this. And that I know will be a positive. Minus 69. What's that, about 10,000?
0.000124.
0.000124. So n equals 0.1 e minus 0.000124 t. Is the answer. Learning is good. Yeah. Well, I never said they're smart as fetuses. Smarter.
Who, me?
Yeah.
I know.
I think good. Now, I'm just trying to be... me being nice to KJ has nothing to do with the fact that he's going to give me his skateboard for 3 months. But you could give me this for 3 months, and then when you come back, I could be so good that it embarrasses you. Like if we had some kind of skateboard competition, if you're like, oh no, my teacher is whipping me. Oh. That would be awkward. That would be awkward. Right, what's next? Scroll down. More. Yeah. I hope you're still trying your homework, because remember predicted grades. Yeah. How many of these did you try?
Yesterday I was sick, so
Yeah.
I do until
No, say no more, say no more. It's okay.
I got to.
Yeah.
I did like 2 questions, then I gave up.
At least you did 3.
What, teacher? I
I'm only joking with you. Right.
Number 4, please.
Number 4. I did number 4 in class.
You did? Well,
I did.
Really?
No,
You didn't?
No, I did.
Yeah, you did.
I just didn't put in the numbers. But I did it it was my example. I did it first order rate law. Remember? Or we had a big discussion about it.
Yeah, then 7 plus.
And I did 7.
You know.
And 8. So your real problem is you're not listening to me in class. No, I've done enough for 44. Because what have I done now? I've done 7 and 8 and 3 and 4. And I talked a bit about how to do 5. So the only one I really haven't done is 6 and 1 and 2.
That was really hard.
No, it was really hard, but you don't have to worry about it because I got confirmation today. You see, what I wanted for the coursework to be about this lesson, ODEs, and in particular ODEs with Hooke's law. Because you know Hooke's law, can I scroll down?
Yeah, so the physics thing.
Yeah, see, what I originally wanted to do with you was Hooke's law. So you know Hooke said F, yeah, well, he actually said F is proportional to X, but we understood that as F equals minus Kx. Now F is dV, well F is MA, and A is dV dt. So you realise, not quite, but you nearly have an ODE. What's the problem with this ODE?
Too many variables.
Yeah, what are the variables on the left? Now remember, M is a constant and K is a constant because they're for the spring. What's the variables on the left? V and T, and on the right, X. We have one too many. So what this worksheet was supposed to do was to guide you through getting to the solution. But not only that, you were originally going to do this. I had a spring like this, and there was, this is going up and down. Okay, so let's imagine it's going down. How many forces on it? Yeah, there's gravity, mg, and there's the from the spring, which is in this case k, x, if this is the equilibrium. And I also wanted you to consider a friction force, B, where the faster it's going, the more friction there is. Now if you write this equation down, the total force will be mg minus kx minus vv. And F, that's ma, mg minus kx minus bv. So this is m dv dt, constant, equals mg, that's okay, minus kx, that's not okay, minus bv, and that's okay, and that's okay. We need to do something about the x, we need to change it into v. So this whole worksheet was the steps you need to solve this. And at the end, you're going to get an answer that looks kind of something like this. Something like E minus T cos whatever, 2T, and maybe there's a 3 here, and there's a 2 here, or whatever. And when you graph it, your graph looks like this. Yeah. So you were going to, in other words, fully solve the spring problem, considering not only gravity, but also friction. So this is 100% realistic. And this is the type of problem that you would do in first year engineering. So I thought this would make a great coursework because in total it's too difficult, but each individual part is manageable if it's broken down suitably. Just like your semester 1 maths coursework. But they said I can't do it because there's too much physics in it. And the only physics I had in it was Hooke's law.
I thought you got confirmation. You just
Yeah, I got confirmation that I can't use it.
Oh, okay.
Steven, but can you do it? Can you go through 9?
No, because the only reason I put 9 in, you see it's about Hooke's law, it was to sort of sneakily, a tricky way to prepare you for the coursework. It's not an exam question, it's the teacher being sneaky in preparing you for a coursework. But now that this coursework isn't approved, then you should need to pretend you never saw it and to move on in your life.
But beyond the class, I would like to know, like, how can it be because cosine, blah blah blah. Because yeah.
This sounds like a
Okay, KJ. But don't ask me too many questions. Let's just go with it. We're going to have a look at number 9.
Teacher,
Yes.
how do you consider friction force acting outward? Because it moves up and down, so it changes the...
Yeah, so the x needs to be a real number that can be positive or negative.
Oh.
Yeah. Okay.
Because too many
Don't
variables.
stop. I don't need your help. I can do it because I made it. I know it doesn't look like I know what I'm doing. I do actually know what I'm doing. Thank you. Okay. Lee!
Huh?
Lee!
Yeah.
I want to do number 9. Be good. Okay, are you looking?
Yeah.
Hooke's law states that f is proportional to x. In fact, the f will act in the opposite direction, so I should write in minus kx. F is the mass times the rate of change of velocity, also known as acceleration. Express this as an ODE. Okay, well, that's part A done. Part B. Show that dv dx, and by the way here x is s, show that dv dx v simplifies to that. Okay, well, dv dx, and what's velocity? What's the definition of velocity? Rate of change of
Displacement.
over,
Time.
what cancels here?
Yeah.
So I've shown that this is the same thing as this. Agreed? Okay, what rule am I using here? This is kind of like the chain rule. C. Use your result from B in A. So now I can say M dV dx V equals minus kx. Okay. D. Solve. Right. V dV equals minus k over m x dx. Yeah? Now, I really don't like writing minus k over m, because as you all know, I'm lazy. But lazy is good because it makes you do things the best and quickest way. So, k is definitely positive, and m definitely positive. So k over m is definitely positive. So I should write this as a constant which reminds me that it's always positive. So I'll write it as omega squared, although you can use any letter. But I would like to remind myself that it's a positive. So my equation now becomes v dv integrate equals minus omega squared dx integrate. Okay, what do I get here? I get v squared over 2 equals minus, oh sorry, I lost my x there, minus omega squared x squared over 2 plus c. Yeah?
Yeah.
Yeah? Okay. So I'll multiply by 2, and I won't bother putting the 2 on the c, because the c just stands for a constant. Yeah. Right, now I need to figure out what the c is. So we will imagine that the spring is pulled out and released. Okay? So if I pull it out and release it, at the beginning, what's the x for the spring? It's the amplitude. It's the maximum. And what's the velocity? 0. Now, if you don't want to use the letter A, that's okay. I'll just instead use x0, the length at the beginning. So what does c equal? C will equal omega squared x0 squared. Okay, so now I get v squared equals minus omega squared x squared plus omega squared x0 squared. Yeah? I think I'll take the... I'm thinking I'll take the omega squared out. I should definitely do that. I'm just wondering if I should take the minus out. I don't think I'll take the minus out. Omega squared x0 squared minus x squared v squared. Okay, what should I do next? Well, I should square root it. V equals omega square root x0 squared minus x squared. Now, of course, there's a plus or a minus. I know it should be a minus because at the beginning, if I imagine it like this, it's going to be heading to the left. So I'll put the minus solution in. Okay, what does v represent? Velocity. And what's the definition of velocity? Yeah, so dx dt. Hey, what's happened again? I've got myself another ODE. Right, continuing. Once it wakes up. So you can see what good thing Dennis's laptop broke. Now I get a new one soon. I just need to wait for the password prompt. Yeah. What? Oh, I'm not talking to you right now. Okay. Minus omega x0 squared minus x squared. So that's dx over square root x0 squared minus x squared equals minus omega dt. Integrate. We haven't done an integration. Well, we have done an integration like this. What I'll do next is I'll divide out the x0 squared. So I'll take that out and I'm left with 1 minus x over x0 squared. And this becomes minus omega t plus c. I just took the x0 out of these two. Now, if I take the x0 out here, what's square root of x0? Yeah, so I'll just put this, square root of x0 squared is x0, so I can think like that. This kind of looks like something we've done. If I use it substitution, if I say let u equal to x over x0, then that means du dx equals 1 over x0. So dx equals x0 du. So I can replace this with x0 du. But that's wonderful because what cancels here? X0's cancel, and this becomes u. And I think if we integrate 1 over square root 1 minus u squared, that's the other one, I think it's sine. It's sine or cos. Yeah. Now, in fact, if I bring the minus back over here, I think it's in the formula book, but if not, I'll just put it on the side note here. If you integrate 1 over root 1 minus x squared, that's sine inverse. If you integrate this one, that's cos inverse. So, this becomes cos inverse u, but u is x over x0 equals omega t plus c. So that means x over x0 equals cos omega t plus c. But let's remember, when the t is 0, x should be x0. So when the t is 0, this should be 1. And the only way this can be 1 when t is 0 is if the c is 0. So we end up with x equals x0 cos omega t. Or if you want to use the usual letters, a cos omega t, a formula that you remember from simple harmonic motion. Yeah. Each step is understandable.
Yeah.
No. Sure. When you square root omega square,
Yeah.
why do you make it negative?
It's two possibilities. Agreed? Plus or minus.
Yeah.
I know from the picture I have in my mind, it's heading to the left if I pull it out to the right. The sign doesn't matter, you know, it doesn't matter. It's only which way you want it to start from, what you call plus or minus. If you called it plus, that's fine.
But omega square is k over m, so even though square root k over m should be positive, right?
Well, no. Well, even if I kept this as k over m,
It should be positive.
yeah, but the minus was here before the k over m.
I mean the next step.
Here?
Yeah, well, when you square root omega square, you put a minus in front of omega.
Yeah.
How do you assume omega to be negative?
But I'm not saying omega is negative, I'm saying this whole thing is negative. Because when you have something like a squared equals b squared, is a is equal to plus or minus b. I'm not saying that the omega is negative, or it's because I took the square root to try and solve for v, I have two answers for v. There's two answers for v. I know I want the minus one. Yeah. Well, this must be Chrissy.
O'Brien.
We started an hour ago.
It was real.
Yeah.
Happy birthday.
I'm sure I will take
But you didn't say that.
It says it on your timetable, and you know last week we started at 2 as well. I'm turning the assessment support into a class.
But you might be busy this week, so we did not.
Yeah.
I'm always busy, but for you I'll make time.
Teacher, for this question, I'm using GP.
Oh yes,
Yeah,
it's a
but
wonderful
I
question.
didn't tell me.
I still cannot
But
get it.
But
I
you
think
said
it's
it
logic
wasn't
for me to
stable, so I
use
just
GP
so I feel like
to
you
solve
guys
this.
have
Yeah.
You're right.
Yeah, but I can't.
Let me do it.
Okay.
Guys, page 40 please. Jerry, please, I'm sick. Give me a break. Page 40. Number 11.
I think it's logic.
Well, I didn't
You did
know
it?
that.
Yeah. Last time?
Person is number 10. Maybe.
I let x equal bracket, yeah.
I'll do 11 first because that's more interesting.
And then?
And then maybe I'll do number 10.
We'll see.
Dude, you're making her feel bad. Cut it out.
Yeah.
As long as you exam validation.
You want to give him some of this? I can't do it. Right, number 11. Whoever made this workbook now, he or she put in some tricky questions. 1046.22 equals 100 plus 100 times 1 plus I, etc., 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 as you can see in the question there, all the way up until 10. Right, so you are right, Andrew. We should use a GP formula here. What's the A?
100.
100. And the OR?
Is
1 plus I.
yeah.
And the OR is 1 plus I power 10.
Mm-hmm.
Yeah. Now here what's nice is the 1 and the minus 1, they cancel here.
Mm-hmm.
So that leaves you just the I.
Oh.
No, it can't. No, this can't be the problem.
Minus I.
No, because I
Yeah, minus I, yeah.
I let the bracket become x, so
That's fine too.
oh, that's right.
That's fine too, that will get you to the answer as well. Would you prefer if I did that? I can't see any problem with letting that equal x. You said let 1 plus I equal x to try and simplify it. Let's do that then, since that's what you tried. Let x equal 1 plus I. So now I get 1046.22 over 100 equals 1 minus x10 over 1 minus x. Yeah? So that's 10.4622 equals 1 minus x10 over 1 minus x. So that is 10.4622 minus 10.4622x equals 1 minus x10. So that is x10 minus 10.4622x plus 9.4622 equals 0. Now, we need to check where the answer might be. So, if I was to put in a number like 1, I'll get 1 minus 10 plus 9, well, I should be more accurate, 1 minus 10.5, plus 9.5. What happens here?
0.
Yeah, actually, so I found one of the solutions, 0. Oh, I don't need to do this, because I tell you the answer is roughly 0 anyways. But one of the solutions is 0, or is it... can we use 0? We can't really use 0, because if I use 0 back here, I'm dividing by 0. So I don't really want to use 0, because although I simplify this problem down, I have to remember originally what it was. And anyways, 0 doesn't make sense, because if I put 0 into this, I'll get 100 plus 100 plus 100 all the way, won't I?
10.
There's no way I can keep adding 100 like this, and this tells me I can't be 0. So anyways, I don't want to be using 0. But I tell you that the answer is close to 0. So let's try maybe I is somewhere between 0 and 1, because I say it's close to 0. I mean, it could be negative as well. So if I is between 0 and 1, let me just add 1 here. There's a plus 1 here, sorry. Then I plus 1 is between 1 and 2. But what is I plus 1? It's x. So I think x is somewhere between 1 and 2. So I feel like I want to start with maybe 1.5 for x. Okay? Whoa! Now I need to use my maybe I can just use your calculator here. Thank you. So let me see what we get here. Now, what's Newton-Raphson's rule? Well, Newton-Raphson says xn plus 1 equals xn minus, and on the top I have my function, which will be xn10 minus, you know the story, and then on the bottom I have the derivative, which will be 10x9, and you know the story. So let me start at 1.5 and see where I end up. Okay, so answer minus fraction, answer power 10 minus 10.4622, answer plus 9.4622 over 10 answer power 9 minus 10.4622. Okay, so let me just write down the numbers as they appear. Come on. x0, 1.5. x1, 1.36. x2, 1.248, etc. So hang on, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, it stopped at 11. So x11 is 1.00999736. So that means 1 plus I is 1.00999736. So I is 0.00999736, which is roughly 0.01, which is 1%. Because what I didn't tell you in this question is I is actually a percentage. I mean, you don't have to do that, but the reason I came up with this question is it's actually a financial maths question. It's a problem in financial maths where you have to figure out what the interest rate is, and the equation is quite difficult because you can't really solve for I because it's a power 10.
What
You can't. There's nobody can simplify this down to just get I equals. The problem is ultimately because, Andrew, in the beginning, the I had a power 10 and a power 1. This is really what is limiting your ability to solve it using algebra.
We do two.
Oh, now you.
Yeah.
Yeah. Happy with that, Andrew? Yeah. 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 So, I was interrupted in my train of thought earlier. I cannot use the maths coursework I wanted to use. Even though my one is awesome, like all my courseworks, I can't use it. I know you won't admit it, but you really enjoyed doing coursework 1. No, don't admit it.
Oh, you made it? Coursework 1.
I make all the courseworks for every maths class here.
I love that.
Thank you.
Really.
No,
It's
thank you.
really interesting.
Thank you.
Did you
And
see my-
don't go overboard though.
Did you see my conclusion?
What did you say?
I feel like compliment about your conclusion.
No,
Oh, that's why I gave you low marks. Yeah.
Yeah.
We don't get like a feedback. I mean, you say my conclusion was bad, but I don't really know what to say.
No problem, because when we're doing coursework too, what I think I'm going to do differently is I'm going to have you submit parts of the coursework in stages, and then at the end you submit everything as one. So we'll look at the conclusion, because I'm trying this with the January students, you know, because they're a little bit, you know. So what I'm doing with them is, don't tell them I said that. Yeah. Don't tell Bruce this. What I'm doing with the January students is I have them submit the coursework in parts. I don't really want to do this because this takes more time, but because of how interesting the conclusion and introduction was, I think I will do this for coursework 2. Yeah. So we will have a separate submission for each part, so I can give you feedback before the final submission then on each part. Happy? Yes. I know, I can't be interrupted again, because what I keep meaning to talk about is what you will have to do for your coursework, okay? So, because of the coursework they have me do, it's a bit annoying, because the coursework I was going to give you focused on just one chapter, but their coursework focuses on 4 chapters. Now, the coursework they have is... Are we finished with the tutorial? You have another question? Yeah, because I want to stop the video before I continue.
That's first you have to differentiate.
Correct, make the derivative equal 0.
Yeah, so that you get x, so the differentiate is x4.
Yeah, it's an x4, and then use Newton-Raphson to solve that.
Right.
Yeah.
I think number 3 answer is wrong.
3f.
If anyone did that.
3f.
Yeah.
Did you try any other question in 3?
Yeah, and then...
And were they right or wrong?
Others are fine, but I tried it like 3 times because of my...
Okay, I can check it. I can check it, but I think you're wrong.
Okay.
And the reason I say this is because instead of writing all these questions down, what I did was I wrote a small program to make all these questions for number 3.
Oh, really?
So, no, Christy, what that means is if the other ones are right, it would seem unlikely that the program made 1, 2, 3, 4, 5, 6, 7 questions correctly and then did something wrong on the 8th one. You know? Now,
I'll try one more time and then...
it could be a bug in my program, but try it one more time.
Let's try one more.
Okay, now can we please talk about the coursework?
Yeah.
Yeah, okay. Let me just stop this